So this video is going to cover section 5.7 in Integrated Course 1, or the idea of it is combining functions. So this is 5.7 in Course 1, and it's combining functions. So this is kind of an important thing. It really uses a lot of the things we've already learned in a different notation, in that function notation. First of all, you have to remember that notation of f of x, which just means function notation, and it's the same thing as y. So these really are the same thing, but we use this notation more. And the f is just like a letter. We usually use an f for function, but we could use a G, a Q, or whatever letter we want, and that's kind of the name of the function. So when we go to do the adding and the subtracting and the dividing and the multiplying in this section of functions, we label them, or we know what they are, by their first letter. So here's my first example and what I mean by that. If I have f of x is equal to 5x minus 7, and then I also have g of x, and g of x is going to be equal to negative 2x plus 1. Then I can say, okay, this one's the f function, this one's the g function. And remember, I say this f of x, g of x, and so they're in terms of x. And this is so we can see input and output all at the same time. So what I mean by that is, what if I would have had something like f of 1 equals 2? That looks kind of strange. Whatever the function was, if I put in 1, I got out 2. So it's like our x and y are both visible at the same time, and that's the idea of this notation for functions, because we like input, domain, output, range, and we like talking about those in a lot of different contexts. So with this one, this chapter, all we're going to do is kind of look at the notation and what it means. So my first example is, what if I have f plus g in a parenthesis with an x on the outside? What does that say, and what does that mean? What that means is, in terms of x, what is f plus g? In terms of x means don't put any numbers into your functions, just leave it in terms of x. So I'm going to take this as f plus g is going to be our function f of x plus g of x. It's kind of the same thing there, f of x plus g of x, f of the same notation. And you'll see it written in both these ways on different tests like SATs and other test standardized tests that you might see. You might see it written either way. But what is it really saying? It's just saying take f of x minus 7 and add it to negative 2x plus 1. That's it. So you're going back to, how do I combine like terms and things like that. So this is a plus, so this one's a little bit easier. So we just look at what's the like terms on both sides. So these both have an x. What's 5 minus 2x? Well, it's going to give me 3x. And it's negative 7 plus 1 is going to give me negative 6. So this is my final answer for f plus g of x, f plus g of x, 3x minus 6. So you might have seen something like this. And what is the difference between the first problem and this problem? Well, we still have f plus g, but this one's not in terms of x, it's in terms of 2. So what it's telling you is put 2 into f plus g. So you could put it, if you already have the function, so a lot of times they make you do the function in the first part, like a, and then b, they have you do the second one. So really what this is saying is take this and put 2 in for x. So I'd have 3 times the 2 minus the 6. So then you would get 3 times 2 is 6 minus 6, which is 0. So my answer is, if I put in 2, I get out 0 on f plus g. If you weren't given the function first, then you would have to write it out, and you could put 2's in these spots and then combine it down as well. But you either are putting in a number or you're leaving it in terms of x, depending on what's in that second parenthesis. So let's look at minus. How does that make it different? What if I had f minus g of x? Well, then we have to be careful of our negative signs. So remember, f is 5x minus 7. And we want to minus g, which g was negative 2x plus 1. And this is where just people mess up the negative sign. When we're subtracting each of these off. The easiest way to get this correct is just to change this sign to a plus, and to change all the signs in the second parenthesis. If you do that, it keeps you from messing up all the double negatives and the different subtractions. If you can think 5x minus a negative, so that becomes a positive, 2x is 7x without changing it, that's fine. But I find it easier to go, okay, now what is 5x plus 2x? Well, that's 7x. What is negative 7 plus negative 1? That's negative 8. And so my answer is 7x minus 8. So when I subtract them, clearly I don't get the same answers if I add them. Okay. Next, what if on the same ones we wanted to multiply them? Okay, so, oops, what question was I at before? What if I had f times g of x? And again, I'm using just the x because those ones tend to be the harder one. If it asks for a number, then you could put the number in to the original, or the number, I guess the number ones, most people just don't get the number ones wrong, but you're putting it into the same formula. So what is this asking? It's asking to take f of x, which is 5x minus 7, and to times it by g, which is negative 2x plus 1. So I'm going to times those. So it's just a FOIL problem going back to multiplication. So 5x times negative 2x is going to give us negative 10x squared. 5x times 1 is going to give us a positive 5x. Now switch to your inside one. Negative 7 times a negative 2 is a positive 14x. Negative 7 times a positive 1 is a negative 7. Then from here, combine your two middle terms that are both just an x, those like terms, and you get negative 10x squared plus 19x minus 7. And so that's f times x of x. Now if I put a number in, I could do it two ways. If I would have been given a 2 here maybe, I could have just gone with writing this and put a 2 here and a 2 here and simplified it that way. I could have simplified it in x's and then put the 2 in to find the 2 answer. So finding the number ones aren't too bad. Last question, or I have 2 more. What if I said, what's f of g of x like this? What am I saying when I say f like a fraction? It just means division. So you're going to write them as a division problem, which would be 5x minus 7 divided by negative 2x plus 1. Now, we can't simplify that because they don't match, and you can't cancel x's or any numbers or anything like that. We haven't got that far in our textbook to learn how to simplify the complicated fractions like this. These are called rational expressions. And eventually you'll learn them, but for today, we just want to write them as a division, and that's it. That's all we have to do. And if you're asked for a number, then you just put the number again in for x, and you're done. And simplify. Okay? What if here's my last quick question. What if I have something like f plus g of x is equal to 4 times 3x plus 1, something like this. What if I'm given this? What are some options that f and g could have been? And what is this saying? Well, we're saying that f plus g is simplified into this here. And I picked this one because it's kind of tricky with that 3 to the x, and it throws people off. So some options, now we could break this up lots of ways. Think about if my f of x and my g of x. What if I think about this as having 3 to the x's? Well, I could have 2 3 to the x's, and I could have 2 3 to the x's here and add them together to get 4 3 to the x's. One of them would have to have that plus 1 on it, though, to make that plus 1. Now, that all I did was break this up into two possible ways. I could have done 3 and 1. I could have done, well, they want you to do, you can't do as easy ones as 1 and then this and then add them. It would work, and I would accept that as a written out answer, but in the textbook it makes you pick some harder ones, so I wanted to make sure I've showed you the harder way to think of this. So think about it. If I took this and I had 2 times 3x plus 2 times 3x plus 1, I could combine these, because there's two of the same things, as 4 times 3 to the x plus 1. Just like I could, if it was 2x plus 2x, I could get 4 x's. It's just the x is very pretty. It's 3 to the x instead of just a number there. But either way, we got back to our original answer. So I kind of wanted to show you that backward thinking with something that doesn't look real pretty with that 3 to the x. Okay. Otherwise, you should be good with the notation on this section, and hopefully you found this video helpful.